Good morning, friends. Let us do some more examples in simple interest and compound interest. Okay. A sum of money becomes 4 times in 20 years at simple interest. Find the rate of interest. Very good. Simple interest. What is the interest? Interest formula is interest equal to PTR by 100. Here, T is equal to time is 20 years and R we don't know. Interest is equal to, it become 4 times. Principal has become 4 times. Right. Money has become 4 times. What does that mean? P plus 3P. 3P is the interest, P is the original amount. Right? Original amount is P. It has become 4 times. That means 3P got added. So interest is equal to 3P. So 3P is equal to P into time is 20 into R by 100. P and P gets cancelled. Interest is equal to 3 into 100 by 20. 30 by 2 is equal to 15%. Right? So it's 15%. Sum of money will become 4 times in 20 years. 20 years, what will it happen? Let's say 100 is the original amount. 100 into 20 into 15 by 100. Right? This becomes 300. So interest becomes 300, right? So total amount will become 400. Okay? We're just refining that. 100, if original amount was 100 and time is 20 years and interest is 15, then P into T into R by 100 is equal to 100. 100 gets cancelled. R then 20 into 15, which is equal to 300. 300 is the interest. This is the interest. And 100 is the original principal amount. Total is 400. Right? Let's get to the next problem. What is it saying here? A sum becomes 2 times in 5 years at a rate of simple interest. Find the rate at which it becomes 8 times at the same rate of interest. Same. Very good. So, interest is equal to PTR by 100. This we all know. In 5 years, it is becoming 2 times. In 5 years, it is becoming 2 times. That means 5 years, what is the interest that is added? Interest that is added is 4P. So, it becomes 2 times. 2 times, no. So, in 5 years, what is the amount that is getting added? 5 years, it is become 2 times means 1 P got added, right? So P plus P becomes 2P, right? Interest is equal to P is equal to P, T is 5 years into R by 100, right? P and P will get cancelled. R is equal to 100 plus 5 is equal to 20%. Okay, 20%. Every year 20, 20, 20, 20, 20 is getting added. So total is 100 in 5 years. 5 into 20 is 100. And original 100 was also there. So it becomes 200. Right? So if an amount, a sum is becoming twice, that means interest rate is 20%. Okay. Now what will happen? With the same amount will be 8 times at the same amount of interest. Okay. In 8 times, amount has to become 8 times. What does that mean? Interest is equal to 7P, right? Then only P plus 1P will be made is equal to P into T we don't know. R is 20 by 100. P and P will get cancelled. Then time is equal to 7 into 100 by 20 to 5 equal to 35 years. Okay? In 35 years. In 35 years, it will become 8 times. Each year, 20, 20, 20, 20 will get added. So 35 into 20 35 into 20, 7 times, 7 times, right? Plus original fee. This is the solution, right? The problem is very easy. Whatever is the interest, it is become two times. What does it mean? If it is become two times means the interest that is getting added is equal to the original principal. Okay, so the interest is equal to PTR by 100, which is equal to the original P is equal to P into time into R by 100. R, what is R? R we simply calculated. R is equal to 100 by 5 is equal to 20%. Now the same original amount, if it has to become 8 times, what does that mean? The interest will be 7p to make it total 8, right? P 7p plus p is equal to 8p, will be 8p, right? 7p is equal to p into t into same r, which is 20 by 100, right? That becomes t is equal to 700 by 20, which is 35, right? Good. So now we have done decent number of problems in simple interest, right? We have done a lot of problems. We have got understanding about what is simple interest. Let's try to understand another important concept in this interest calculation, that is compound interest. Like we had earlier discussed, compound interest will generally give more interest than the simple interest. And let's just look at how compound interest works. Okay, let us take this example. Let us take this original example that we had discussed earlier also. Right. Let us make this even more simpler. Okay. Earlier we had discussed, right? If original amount, let's say, original amount was 100 rupees. Let us revisit the simple interest example, right? Let's say we have an original 100 rupees, right? We have 100 rupees. And then each year, if it is interest rate is 10%, each year 10, 10, 10, 10 will get added, right? Each year 10, 10, 10, 10 will get added, right? No. So what that means is at the end of first year it is 110, at the end of second year it is 120, at the end of third year it will be 130, likewise. Okay. But in the case of compound interest, what will happen is first year this 10% will get added, which is 100 into 10 by 100. 10% means 10 by 100, right? 100 into 10 by 100. 10% get added, which is 10 rupees. If there was 100 rupees, first year 10 rupees will get added. Now this is 10. What will happen? This amount will be added. This interest amount will be added to the original principal amount. That becomes 100 plus 10, which is equal to 110. At the beginning of first year, at the end of first year, the amount would be 110 rupees. Right. At the end of first year. At the end of first year, amount would be 110 rupees. Now what will happen? 110 rupees, again 10% will get added. So 10% of 110, which is 11 rupees, right? 10 by 100 into 11. Okay, again it will get added. So in the first year, in the beginning it is 100 rupees. At the end of first year, it will become 110 rupees, right? Now, then what will happen on this 110? Again 10 rupees get, and again 10% of 110, which will become 11 rupees. That 11 gets added. So by the end of second year, this 110 plus 11, which is equal to 121. Right. Now, on this 121, so here we were adding 10 rupees, 10 rupees, 10 rupees every year. But here what it is adding, whatever interest that is coming, we are adding to the original principal amount and calculating 10% on the total amount. So we start with 100, and on the first year, this it becomes 110. Here also first year it becomes 110. That is fine. In the second year, 10% of this 110 gets added here. Whereas in the second year here, 10% of the original 100 only will get added. 10% of original 100. So every year it will be 10, 10, 10, 10 only. But in this case, 10% of 110 will get added. So which is 11 rupees. that will get added to 121. Now, this is this is by the end of second year. By the end of second year, we would have become 121. Then by the end of third year, what it will happen? In third year, 121 in 10% again in 121. 10% of 121 is 1 by 10 of 1 by 10 of 12.1. So 12.1 will get added. That becomes 133.1. Again, at the end of third year, this is the end of third year, it will become 133.1. Now, again, after for fourth year, 10% of this one, right? 10% of 133, 13.31. That will get added here. So we start with 100. We start with 100. Okay, we start with 100. On the first year, we'll add 11. First year, we'll add 11. So at the end of first year, it will become 110. So at the end of second year, you will add one more 10% of this 110, which is 12.1. At the end of second year, it will become 121. At the end of third year, we'll add again one more 10% to this 121, which is we'll add on that 12.1. So it will become 133.1. At the end of fourth year, we will again add 10 more percent to this 133.1. That becomes 13.3. 13.3 plus 133.1 is 146.4. Right. You'll keep on adding likewise. So now if you observe, because you're adding on the additional interest also, whatever interest that is getting generated, 10% of that every year, the amount at the end of the year will always be higher than what exactly it is for. It is for simple interest. So for example, in the first year it will be same. It is 110 and 110 in both the cases. But in the second year it becomes 121. Here it becomes 120. In the third year, by the end of third year, it becomes 133. It is 130 only. In the fourth year, 146. It keeps on increasing. By the end of sixth year, it will becomes 177. Here it becomes 160 only. Right? By the end of 6 years. In 6 years, each year 10 only got added. But here, each year the interest that is getting added. First year only it was 10, then 11, then 12, then 13, then 14.6, then 16.1, etc. etc. Right? In the seventh year, by the end of seventh year, what will happen? This 177 plus 1 plus 17.7. This plus this. That becomes what it is at the end of seventh year. So you understood, right? How simple interest and compound interest work, right? Okay. Now let's try to solve some problems in compound interest. Find the compound interest. Find the compound interest on 70,000 for 4 years at the rate of 14% per annum compounded annually. Very good. 14% per annum compounded. What does that mean? The first year, at the beginning, it is 70,000. At the beginning, it is 70,000. In the beginning, it is 70,000. Then what will happen at the end of first year? First year is the 70,000 into 70,000 into 14 by 100. Right? 9800. 9800 is the interest that they have to pay, is the interest that they have to pay at the end of first year. Right. So at the end of first year, what will be the amount? 70,000 plus 9800. That becomes 79,800. Now, now in second year, what they have to pay? 7900, 79,800 again into 14 by 100. 79,800 into 14 by 100. This becomes 11,172. 11,172 that they have to pay per second year. So the amount will become 79,800 plus 11,172. That is this amount. Right. Now again for third year what they have to pay? Again 14 more percent on this one. 14.1%. That is 0.14 into this one. 0.14 into 90,000. Right. This is 12736. 0.14 into 97. 0.14 into 90, so 0.14 into 90,972 will become 12,736. Right. This they have to add. So this plus this will become this. Now at the end of third year, this is the amount. At the end of third year is this amount. Now for fourth year, they have to again add 14 more percent on this. So this into 14% is equal to 14,519. Right. This plus 14,519 will become this. So at the end of 4 years, they have to pay this. Okay. So 70,000 on the first year, 9,800 gets added. And this is first year, for the first year. This is end of year. This is end of year. End of first year, what is the amount? End of second year, what is the amount? End of third year, what is the amount? End of fourth year, what is the amount? So during first year, so start to first year, what is the amount before the first year ends? This is the interest that is accrued. Then during second year, this is the interest. During third year, this is the interest. During fourth year, this is the interest. Right? During fourth year, that means between third year end and fourth year end, this is the interest. So this plus one will become this. You don't need to worry about this. Okay, 70,000. First year you have to pay 9,800. 70,000 plus 9,800, 79,800. Second year you have to pay 11,172. So second year, end of second year, you have to repay this plus 11,172 will become 99,72. At the end of third year, during third year, you have to pay this much interest. So end of third year it will be end of second year plus whatever third year interest that has come up. Okay. End of second year is 90,972. And in third year, this is the interest that has accrued. So this plus this will become whatever is the amount that they have to pay at the end of third year. Similarly, at the end of fourth year is whatever fourth year interest is 14,519. This plus this will become what? 11,000, 1 lakh 18,227. He has taken 70,000, right? 70,000 and he has to pay 1 lakh 8227 as the total amount, right? 1 lakh 18,227 minus 70,000 is the amount that has accrued as interest. So what is the total interest? Interest is equal to 1 lakh 18,227 minus 70,000, which is equal to 48,227. This is the amount of interest at the rate of interest rate, which is 14% per year. Right? This is the calculation. The other way of doing this calculation is for compound interest. Amount is equal to principal into 1 plus r by 100 whole power t. This is the formula. Okay, 1 plus r by 100 whole power t. What is p here? P equal to 70,000. 70,000 into 1 plus r by 100. This is 14 by 100. Whole power 4. That means 70,000 into 1.14 power 4. 1.14 power 4 will become 1.6, 1.69. 1.69 into 70,000. 1.69 into 70,000 will again give you this one. 1 lakh 18,227. Okay. See, every year So let's derive this calculation also. In the first year, it will be P. Let's start it is at P. Then what is happening? In the first year, 1 plus R by 100, right? At the end of first year. At the end of first year is 1 plus R by 100. Now, that is 1 plus R by 100. P into 1 plus P into 1 plus R by 100 is this. Now, at the second year, this is the amount. On this total amount, again into 1 plus R by 100. Okay, at the end of second year, again into 1 plus R by 100. This is for 2 years. This entire amount will become at the end of second year is this. Now at the end of third year, this again into 1 plus R by 100. Again into 1 plus R by 100. Right, this total amount. Now this is this entire amount being this three times 1 plus R by 100. This is at the end of third year. If we have to do fourth year, then this again into 1 plus R by 100 into 1 plus R by 100. What does that mean? This 1 plus R by 100 is getting repeated. So P into 1 plus R by 100 power 4. This is the total amount, right? If it is 4 years. Similarly, if it is for n years, it will be P into 1 plus R by 100 total power n or t, whatever you call it. If it is n years, 1 plus R by 100 into power n. Okay, this becomes your total. This becomes your total amount. Now, what you have done? We have done the same calculation here also. So 70,000 into 70,000 into 1 plus R by 100 raised to 4 equals how much? This is the question. R is equal to R equals to 14%. So 1.14 raised to the power 4 into 70,000. This is the answer. This is the total amount that has to be paid by the end of 4 years. Okay, remember this formula. This is amount. Amount is equal to P into 1 plus R by 100 whole power n. Okay, amount is equal to principal plus interest. Okay, what that means? If you have to calculate interest, interest would be interest would be interest is always amount minus principal equal to P into 1 plus R by 100 whole power n minus P. If you have to calculate interest. Okay, this is the derivation. Okay, now next one, let's look at another problem. 60,000 amounts to if 60,000 amounts to 68,694 in 2 years, then find the rate of interest. Okay, so what is roughly the interest rate? 68,000. What is the interest rate? What is the interest? 68,694 minus 60,000. Okay, this is 86,94 in 2 years. 86,94 in 2 years. Okay, now if it was simple interest, we know simple interest is always less than compound interest. If it is more than 1 year time period, if it is one time period, then simple interest should be equal to compound interest. If it is only 1 year, otherwise simple interest is less than compound interest. Okay, if it was 86,94 in 2 years, that means what could be the simple interest? What could be simple interest? Each year it would be 86,94 by 2, right? Which is roughly 4347 each year interest. Each year interest would be 4347 by whatever is 60,000. This is the interest rate. If it is simple interest rate is 4347 by 60,000. So roughly it is around 0.7%, 0.7 something, right? 4347 by 6 is equal to 7.2 something, is equal to 7.2. 43 this way, 40 this interest rate, right? 7.2%. Okay, this by this. 7.2%. Now, we know compound interest, the amount of compound interest is always more than this thing. That means with a lesser interest rate, lesser interest rate, compound interest, compound interest will give more interest amount, right? Will give more interest amount, right? So, for example, in this earlier example, in this earlier example, so to achieve 160, compound year has took 5 years only, whereas it took 6 years in simple interest. What does that mean? Even with lesser interest rate also, probably somewhere around 9 or something, compound interest would achieve. In 6 years, if I have to achieve 170, in 6 years, if I have to achieve 160, we don't need 10% interest rate in compound interest. It can be lower also, right? Because compound interest is faster in terms of giving interest. Okay, because it is calculating interest on interest also. So compound interest rate can be lower. Then also the interest would be equal to the interest amount would be equal to simple interest. So here, if simple interest itself is becoming 7.2% in this case, then compound interest has to be less than 7.2%. Okay, let's try with 7. When you try with 7, first year 4200, first year for second year 44 and 4494, and then that becomes 686 4200 plus 4494 will be becoming at the end of second year 68694. This is one way of solving the problem. This is an easy way of solving the problem, right? There is another difficult way, which is the original way. What you have to do, 60,000 into 1 plus r by 100. We don't know what is the time period. Oh, no, time period is already given. Square is equal to 68,694. That means 1 plus r by 100 whole square is equal to 68,694 by 60,000. 1 plus r by 100 is equal to 68,694 by 60,000. 60,000, which is equal to 68, 1.14 roughly. 1.14 roughly, that is the square root of 1.14, which is equal to roughly 1.07. That means r is equal to 1.07 minus 1 is 0.07 into 100. This is equal to 7%. Okay, so if you have to do the complex way, then you have to calculate the square root also, right? So the formula is, what is the amount? What is the amount in 2 years? Amount is equal to principal into 1 plus r by 100, 1 plus r by 100 into whatever is the time period. This is the formula. This is the formula that we had discussed earlier also. Principal into 1 plus r by 100. This is the formula. Okay, amount is equal to principal into r 1 plus r by 100 whole power t or whole power n, whichever you take. Okay, 1 plus r by 100 whole square is equal to 68,694. 1 plus r by 100 whole square is equal to 68,694 by 60,000. That means 1 plus r by 100 equal to 68,694 by 60,000 is roughly 1.14. 1 plus r by 100 is equal to square root of 1.14, which is equal to 1.07. So r becomes 1.07 minus 1, which is 0.07 into 100, which is 7%. Okay. So this is the same example that we had taken just to showcase what exactly is the difference between interest rates. So one thing that we have to understand is, with a lower interest rate, compound interest will still give the same amount. Okay, if it is the same interest rate, compound interest rate, the interest would be much higher. Interest would be higher than what we get from simple interest, right? Now, in how many years the sum of 10,000 will become 10,920 if the rate of compound interest is 4.5%. Simple. 4.5% is also given. So each year 4.5%. Let's do calculation. 4.5%. First year 150 will get 450 will get added. So 10,450. Then second year again 4.5 of 450, which is another 420.25 will get added. So that becomes 10,920.25. Right? 10,920.25. So this is after second year in how many years? It will become 10,920 after 2 years only. So to have an easy trick, every year 450. So in 2 years, simple interest, it will take roughly 900. So compound interest, it should be roughly around 2 years. Just to for you to get some rough estimate, because we need to have these tricks. Otherwise, calculating this entire difficult calculation and long numbers will take a lot of time. So you need to know what is the rough answer. Okay. In 2 years, if it was simple interest, it would have been 4.5% of 10,000, which is 450 per year. 2 years, it would have been 900. So the compound interest rate should be greater than, uh, so in 2 years, the amount of compound interest would be greater than 900, right? So it is 920, which is close to 2 years. That's why we tried for 2 years and it worked out for 2 years. Okay, cool. Then next one. Suppose 1,000 is deposited for 3 years in an account paying 8% per year compounded annually. Find the amount. That means 8% per year, three times that we have to do. Okay. One option is like this. 8 calculate 8% first year 80, then 1,080. Then second year 8 into 1,080, which is 86.4 into 86.4, which is 1,080 plus 86.4 is 1166.4. Then again into 8% into 8 by 100. Right? Into 8 by 193. So this plus this is equal to 1259.71. Okay, this is one way of calculating. Otherwise, you can do another way of calculation. Amount is equal to principal into 1 plus r by 100 whole power n. This is the formula. Principal is what? Here 1,000. 1,000 into 1 plus what is r? 8. 8 by 100 whole power 3. 1.08 whole power 3 into 1,000. 1.08 whole power 3 is equal to 1.259. 1.2597 into 1,000. This is equal to 1259.7. Okay. This is one way of calculation. This is one way of calculation. Otherwise, this is another way of calculation. Okay. In either case, please be. But while you do this calculation, right? You don't need to worry about calculation beyond two digits. So, for example, 1.08. 1.08 power 3. Likewise, 1.08 into 1.08. 1.08 square is equal to 1.1664. So you don't need to worry about all of this. You just make a shortcut 1.17. Okay, 1.17 into 1.0. Don't go beyond three digits in any point. 1.17 into 1.08. This equals 1.26. 1.26. Roughly, this is the number. Okay, don't go beyond to this 1.26. Just 1260. We would have got 1260 with this approximation. 1260, or the exact number is 1259.7. So we are fine with this kind of approximation. Okay, you can go to two decimal digits. You don't need to go beyond two decimal digits. Okay, in some cases you can even approximate with one decimal digit. Then you will have to do multiplication with two digit numbers only. Don't go beyond three-digit numbers. Okay, don't go beyond two decimal digits. Okay, so this is another easy problem. Find the compound interest on 8,000 at 15% for 2 years compounded annually. 8,000 first year, 8,000 into 15%, that is 1,200. That becomes 8,000 plus 1,200, 9,200. Again, second year, again another 15%, 1,380. This plus this is this. You don't need to worry about if you have to wait for one more year. If you wait for one more year, then then this is what you have to pay. So 8,000 plus 1,200, this is 9,200 plus 1380 is 10,580. So this is the amount. Another way is amount is equal to principal into 1 plus r by 100 whole power n. So principal is 8,000, 8,000 into 1 plus 15 by 100 whole square. 1 plus 15 by 100 is 1.15 square into 8,000. 1.15 square is 1.3225. You can directly approximate it. You don't need to worry to go till n. 1.31 into 8,000. 1.31 into 8,000 will become 1.32 into 8,000. You can make this approximation. 1.32 into 8,000 will become 1,560. 10,560, which is also closer. This is close to this. In exams, you will be given these four options, right? You'll be given four options. So with basic approximations, you'll be able to understand what exactly is the answer. Good. Hope you have understood these cases. Let us do few more exercises in the next session. Hope you have understood. The important thing is amount equal to principal into 1 plus r by 100 in compound interest. You need to understand what is the difference between simple and compound. Simple interest with compound interest with the same interest rate, the amount of interest would be higher. If the total interest has to be same, interest amount has to same, then compound interest can achieve that with a lesser interest rate. Okay. And while doing the calculations, you need to know how to make approximations. And while calculating for compound interest, to know how many years it takes, you need to make a rough estimate with the simple interest first. Then you can get to a closer approximation of how many years does it take for compound interest rather than solving square roots and all. Okay. Solving square roots will become a big problem otherwise. So what I suggest is instead of solving for square roots, you should make a rough estimate of how long does it take, what is the time period using simple interest. Then you can get a close approximation for complex interest, compound interest also. Okay. All the best, guys. Hope you have understood this. We'll do more examples, more problems in the next sessions. We'll do slightly more complex ones in the later sessions. Right. All the best, guys. Thank you. Bye bye.